A pleasant greetings to all. In this video, I am going to explain how to draw signals from an expression. Consider the problem 1. A signal is described by x of t is equal to r of t minus 4 minus r of t minus 5 minus r of t minus 6 plus r of t minus 7, where r of t is the unit ramp function starting t is equal to 0. The signal x of t is represented as 4 options are given. Here I am going to find out what is the actual waveform for this given expression of the signal. The first step number 1, I am going to write the same expression again. Put 1 dash and put r of t minus 4, then plus put 1 dash r of t minus 5 plus r of t minus 6 plus r of t minus 7. Here I have to put the coefficient. So what is the coefficient here? Plus 1. What is the coefficient? Minus 1. Here what is the coefficient? Again minus 1. And the last term, what is the coefficient? Plus 1. And next what I am going to do? For the corresponding coefficient, I am going to find out what is the initial and what is the final slope for this t minus 4. In the similar manner, I am going to find out the final and initial slope for all the points given. Okay, so final slope minus initial slope. I am going to write the same expression once again, and here positive 1. So plus 1 means what should be the final slope? That is plus 1. The initial slope should be 0. The final slope minus initial slope r of t minus 4. And plus write the final slope minus the initial slope. Here what is the net value? Net value is minus 1. Minus 1 means what is the initial slope? Initial slope is the previous one final slope, that is plus 1. So here minus 1 and the final slope should be 0. Then only we get the answer minus 1. So the next part is over. R of t minus 5 plus here the net value is minus 1. Here we should find out final slope minus initial slope. The previous term, which one is the final slope? 0 is the final slope. For this case, the 0 is the initial slope. And what about the final slope? It should be minus 1. Then only we get the net value as minus 1. And plus, here also find out final slope minus initial slope. So previous case the final slope is minus 1. That should be the initial slope from our case. So minus of minus 1. What is the final slope? That should be 0. Then only we should get the answer plus 1. 0 minus of minus 1 should be plus 1 r of t minus 7. So all the points we should know the final and initial slope. And after finishing this, I am going to draw the signal waveform for this given expression. So first t minus r of t minus 4. So t minus 4 should be 0, t is equal to 4. Then t minus 5 equal to 0, t is equal to 5. T minus 6 is equal to 0, therefore t is equal to 6. In the similar manner, t minus 7 equal to 0, so t is equal to 7. 4 points, the signal changes occurs, that is 4, 5, 6 and 7. So first of all, I am going to mark the point here. This is 4, then 5, 6 and 7. Then I am going to draw the signal waveform. See, what is the final slope for the point 4? Final slope is 1, initial slope is 0. So initial slope should be 0 and final slope is plus 1 up to 0.5. In the 0.5, what is the final slope? 0. And what is the initial slope? +1. Okay. At point 6, what is the final slope? Final slope is -1. And what would be the initial slope? Initial slope is 0. And point 7, what is the final slope? 0. What is the initial slope? Minus of -1. Option A is the correct answer for this problem. Next, draw the signal waveform for the following expression. Here also, I am going to rewrite the same once again. X of t is equal to put 1 dash u of t minus 1 plus put 1 dash u of t minus 2 plus put 1 dash u of t minus 3 plus put 1 dash u of t minus 4. Because from the coefficient, first of all, we have to put the coefficient in the blank space. From the coefficient only, I am going to find out the final amplitude and the initial amplitude. After getting the final and initial amplitude, we can draw the signal. So for that reason only, I am going to find out the coefficient. So here coefficient is +1. And what is the coefficient? Again +1. Here -1 and here also -1. So next I am going to find out final amplitude minus initial amplitude. For the previous case, final slope minus initial slope for the ramp signal. Here this is the U-step signal. So final amplitude minus initial amplitude. So what is the net value? That is +1. Okay, so final amplitude is +1. Initial should be 0. And next, for this next case, final minus initial amplitude. So what is the final amplitude? The previous case, the final amplitude is the initial amplitude for this case. So final amplitude is -1. Okay, what is the net value? Net value is +1. How we'll get the +1? 2 minus 1, then we'll get a +1. So final amplitude is 2 and initial amplitude is 1, u of t minus 2. Plus, here also find out the final amplitude and the initial amplitude. So what will be the final amplitude? Here find out the final amplitude. In the previous case, what is the final amplitude? That is 2. 2 is the initial amplitude for this case, -2. What is the net value? -1. So it should be 1. 1 minus 2. So final amplitude is 1 and initial amplitude is 2. U of t minus 3. And next, find out the final and initial amplitude for t minus 4. So final amplitude minus initial amplitude. So the previous case, the final amplitude is the initial amplitude for this case. Final is 1. So initial is 1. What's the net value? -1. So final amplitude should be 0. So all the values are known. Using this final and initial amplitude and using the delayed signals, we can draw the signal waveform. So before drawing the signal waveform, first of all, we should know the points. So t minus 1 equal to 0, t is equal to 1. T minus 2 is equal to 0, t is equal to 2. T minus 3 is equal to 0, others, t is equal to 3. T minus 4 equal to 0, t is equal to 4. Next, I am going to draw the waveform. To draw the waveform, first of all, I am going to mark all the points. So 1, then 2, 3, and last one is 4. So first say here, u of t minus 1. First take u of t minus 1. Here what is the final amplitude? Initial amplitude 0. So this is the initial amplitude and final amplitude may be 1. So up to this, have to draw. And next for u of t minus 2. What is the final amplitude? What is the initial amplitude? Is the 1 and final amplitude is 2. This is a unit step signal. Okay. And then for u of t minus 3. What is the final amplitude? Final amplitude is 1. And what will be the initial amplitude? And next you have p minus 4. What is the final amplitude? Final amplitude is 0. So this is the 0 value and initial amplitude is. So this is the waveform obtained for the second problem. Thank you. Have a nice day.